Right, this is Honors Pre-Calculus Unit 3, Lesson 7, talking about transformations of functions. This is something that I've actually already talked a little bit about when we talked about function families. Function families are function families because they are classes of families that can be produced by transforming the parent function, right? So let's take a parent function that's not listed in this lesson, y equals sine x. It's just a really good example of the transformations that can occur. Okay, so first I want to take and multiply. I'm going to leave sine x here. I'm going to multiply sine x by 2. So by multiplying by sine x by 2, I've made the amplitude, I've stretched things vertically. I've made them twice as tall. If I put a 3 here, then make them 3 times as tall, 4 times as tall. If I add a slider, you can imagine if I make a bigger, it gets taller. If I make a smaller, it gets smaller. When a is 1, it makes no change. When it's less than 1, it actually compresses it vertically. When it goes negative, it flips it vertically. Negative 1 would flip it vertically, just vertically as is, without stretching, and then stretching it taller, but negative, flipped vertically. Okay, so that's the effect of multiplying sine x by something in front. It has the effect of stretching vertically. Call it a vertical dilation. Okay, whereas if I put the multiplier on x itself, like 2 here, it actually compresses it. Now, vertical stretch is what happened when we put a 2 in front, but when we put a 2 inside, it squeezes it. It actually has the opposite effect. And so I want you to remember this mantra: x is oppositesville. Whatever you do to x has the opposite behavior of what you might think it would do. The reason is it treats every x as if it were twice as far out. So it thinks, the function thinks, that we're twice as far out along the x-axis as we are, and so things happen quicker. Okay, so it actually has the effect of compressing. So everything is twice as frequent or squeezed. If I put in a half, it becomes stretched, right? So dividing by 2 stretches it. If I put a slider here, as a gets bigger, it becomes more and more compressed. As a gets smaller, it becomes more and more stretched. And as a goes less than 1, it becomes more stretched vertically. As a goes to 0, it becomes flat. And as a goes negative, it flips it horizontally. It flips it over the y-axis. Now, sine has the effect where flipping it vertically and flipping it horizontally result in the same thing. But it's actually flipping it horizontally by changing the sign on the multiplier on x. Okay, so horizontal compression and stretching is what happens when you multiply x by something. Okay, now let's do some addition. So I want to add. So I'm going to add something to the whole function. If I add 2, it shifts everything up 2. If I subtract 2, it shifts everything down 2. Translation down. If I add a, I can increase it and raise it by adding a slider on a and going up. As a goes down to 0, no change. As a goes negative, it goes down. So we can move it up and down. Okay. And then finally, if I put an addition term in x, remember x is oppositesville. So if I add to a, you'd think it would move it. Let's just add 1. If I add 1, you'd think it would move it right, but it does the opposite. It moves it left. Okay? So add a. As a gets bigger, it moves further left. As a gets smaller, it moves further right. Okay? So as a gets smaller, it moves further right. Okay, so let's combine some things here. So I can add sliders now for all of these. So I can say a sine x, a sine bx, and I'm going to put parentheses bx plus c, and I'm going to do this. I'm going to say plus d, and I'm going to add sliders for all of them. So as A gets bigger, it becomes more and more stretched vertically and horizontally. As A goes negative, it flips vertically and horizontally. As B is multiplying the x, so as B changes, it becomes more compressed when it grows horizontally, more stretched horizontally when it goes smaller. When it goes negative, it becomes flipped over the y-axis. Okay. C shifts it, so as C gets bigger, it moves left. As C gets smaller, it moves right. And as D moves up, the whole thing moves up. And as D moves down, the whole thing moves down. Okay? So all of that applies to any function. You can do this literally to anything. I use sine x. I can use absolute value of x. Y equals the absolute value of x. Okay? So I can add a slider to A in front, B here. I can do plus C to the x. Note when you do the plus C to the x, you need to put a parenthesis around the x and put the C in the parentheses. And plus D. Okay, I can add sliders for all, right? And as A becomes stretched vertically or vertically for A, B stretches horizontally, and they seem to have the same effect, but not exactly. Okay, notice it never goes down because it flips horizontally, not vertically. C shifts it to the right, shifts it to the left as C gets bigger, and right as C gets smaller. D goes up and down. And I can animate this. Okay, and we can have a bird flying all over the screen. Right, so hopefully that helps. So these are transformations that can be applied to any function, literally any function.